Welcome to all. In this video, we are going to discuss about Data Encryption Standard. Content or Introduction to Data Encryption Standard, Data Encryption Algorithm Steps, Initial Permutation, and finally Key Transformation. First one, Introduction to Data Encryption Standard. The Data Encryption Standard is a symmetric key algorithm for the encryption of digital data. Here, both the sender and the receiver will use the same key to encrypt and to decrypt the data. For example, if the sender uses key value 5 to encrypt the plain text, then the receiver will also use the same key to decrypt the data. Data encryption standard is based on the Feistel block cyber. Data encryption standard uses 16 rounds of the Feistel structure using a different key for each round. Here, the encryption algorithm takes 64 bits of plain text and a 56-bit key as the input and produces 64 bits of cybertext as the output. The decryption algorithm takes 64 bits of cybertext and a 56-bit key as the input and produces 64 bits of plain text as the output. Here the block size is fixed. We know block cyber is an encryption method which divides the plain text into blocks of fixed size. In a data encryption algorithm, each algorithm has an equal number of bits. Actually, the initial key consists of 64 bits. Before the data encryption standard process starts, every 8th bit of the key is discarded to produce a 56-bit key. That is, bit position 8, 16, 24, 32, 40, 48, 56 and 64 are discarded. The discarding of every 8th bit of the key produces a 56-bit key from the original 64-bit key. Data encryption standard is based on the two fundamental attributes of cryptography. One is substitution and second one is transposition. The substitution is also called as confusion and transposition is also called as diffusion. Data encryption standard consists of 16 steps, each of which is called as a round. Each round performs the steps of substitution and transposition. Data encryption standard algorithm steps. In the first step, the 64-bit plain text block is handed over to an initial permutation function. In the second step, the initial permutation performed on plain text. In the third step, the initial permutation produces two ops of the permuted block, says left plain text and right plain text. In step 4, each LPT and RPT, that is left plain text and right plain text, has to go 16 rounds of encryption process. In step 5, LPT and RPT are rejoined and final permutation is performed on the combined block. The result of this process produces 64-bit cybertext. Initial permutation. The initial permutation is performed before the first round. For example, it says that the initial permutation replaces the first bit of the original plain text block with the 58th bit of the original plain text and the second bit with the 50th bit of the original plain text block and so on. The resulting 64th bit permuted text block is divided into two offs block. Each off block consists of 32 bits and each of the 16 rounds. Last one is key transformation. Initial 64-bit key is transformed into a 56-bit key by discarding every 8th bit of the initial key. From this 56-bit key, a different 48-bit subkey is generated during each round using a process called key transformation. For this, the 56-bit key is divided into two ops, each of 28 bits. Thank you.